Hi students, this is your tutor Namonga, and in today's tutorial we're going to look at geometric progression that comes in paper 2 with a total marks of 7. So we are going to specifically look at how to solve GP questions that have fractions. So this particular question is from 2018, the GCE paper. So in a geometric progression, the third term is 2 over 9 and the fourth term is 2 over 27. So we're supposed to find the three questions there. So basically, geometric progression, it's either they're going to give you fractions or the normal numbers, like maybe 4 normal integers without fractions, but you solve them the same way. You come up with two equations that you're supposed to solve simultaneously and get the required values. So I hope you follow through. So the formulas for GP are given on the first page of math paper 2, except for this one here, the sum to infinity, which is given by a over 1 minus r. So let's get straight into solving this question. So here we're told that the third term is 2 over 9 there. So solution. So for the nth term of a GP, we know that the nth term of a GP is given by an is equal to ar n minus 1. A is the first term, an is the nth term, a is the first term, r is the common ratio, and n is the position of the term. Okay, so if we're talking about the third term here, meaning our n is 3, so it's going to be a3 is equal to, we don't know a and we don't know r, it is what we're looking for, the first term and the common ratio, 3 minus 1. But we've been given this a3, it's there, it's 2 over 9. Don't know what's happening. Okay, 2 over 9, it's clear now. Okay, so here where there's a3, I'm going to put 2 over 9 is equal to a r, 3 minus 1, that gives us a 2. This will be my equation 1. Okay, then our equation 2 come from the fourth term. So here the fourth term is 2 over 27. So again we'll say a4 an, it's supposed to be, this is a general formula, an is equal to a r n minus 1. So our n is 4 this time around, so a4 is equal to a r, okay, let me just zoom in, 4 minus 1. a4 is given also, it's 2 over 27 is equal to ar to the power 3. This will be my equation 2. Okay, those are our two equations. Please, you should be able to find these two equations. Then now we're going to solve these equations simultaneously. So what you can do is, you just look, you have equation 1 and equation 2. You look at the equation with a higher power. This one has a higher power, this one has a power of 3. Okay, this one has a power of 3 and this one has a power of 2. So you divide the one with a smaller power into the one with a bigger power. So divide, okay, divide equation 3 by equation 2. So when you get used, you won't even be writing these steps. I'm just writing for you to follow through. So I'm first going to write my equation 2. My equation 2 is here to be 2 over, okay, 2 over 27 is equal to ar to the power 3. Then my equation 1 is this one, so I'll divide this by 2 over 9, and I also divide this by ar to the power 3. Okay, no, ar to the power 2, sorry, ar to the power 2. So here a and a will cancel, right? Then here there are 2 r's, here there are 3, meaning this one will cancel and here will remain with 1 r. Okay, then the rules of division for fractions, we know that this line represents division. When there's division, you change it to multiplication and then you swap the fraction on the right hand side. So what I'm talking about is this. This is the same as 2 over 27 divided by 2 over 9. So you change this to multiplication and swap this. So this becomes 2 over 27 multiplied by 9 over 2. Okay, so this and this cancels, and then 9 here 1, 9 there 3. So this is 1/3. Okay, so here I'm going to have 1 over 3 is equal to r. Here we've just remained with 1. Everything has been cancelled. So 1 is equal to 3r. To get the value of r, we divide by the coefficient on both sides. This and this goes. R is equal to 1 over 3. Okay, there, our R, which is the common ratio. So found R. Find the first term and the common ratio. So found R. So remember we're solving these two equations. When you find the value of 1, you now go to the one with the lowest power. From the two equations you made, you have 2. This one has a power of 3 and this one has a power of 2. You pick the one that has a smallest power so that you don't have difficulties. And you substitute the value found. So from equation 1, we know that 2 over 9 is equal to AR to the power 2, right? And we have the value of R. The value of R is 1 over 3. So 2 over 9 is equal to A, open brackets, 1 over 3 to the power 2. I'm putting this in brackets because R is squared here. So this is going to be 2 over 9 is equal to A. This squared applies to everything in the bracket. So to be 1 squared and 3 squared. 1 squared is 1. 3 squared is not 3 times 2. It is 3 by 3. So 3 by 3, 9. Okay. So then this is 2 over 9 is equal to 1 by A. It is A. Please, my A and 9 should look different. And then over 9. So then we cross multiply. You can cross multiply. You put your arrows there. 2 by 9. 2 by 9 is 18. Is equal to 9 by A. 9A. You can't say A9. You start with a number and then the letter. So to get the value of the variable, you always divide by the coefficient. The coefficient is simply a number written before a letter. So over 9 on both sides. So this and this cancels. And 9 into 18, 2. So 2 is equal to A. Or A is equal to 2. So we're done with question 1. We found the value of A, which is the first term, is 2. And the common ratio is 1/3. Then moving on to the second question there. Find the sum of the first 5 terms of the geometric progression. So the sum of the geometric progression, there are 2 formulas. If you check the first page of paper 2, you'll see that there will be 2 formulas. The first formula is the formula for when r is less than 1. And the second formula is for when r is greater than 1. So if you look at our r is 1/3. 1/3 is less than 1, right? Yes, so we'll pick the formula for the sum when r is less than 1. So I'm going to question, please bear with me. I'm holding the phone, so things are just scattered here. So the sum, okay, the sum, waiting for it to focus. Okay, the sum will be given by, the sum is A over 1 minus r to the power n over 1 minus r. Okay, the sum is given by A, open brackets, 1 minus r to the power n, close brackets, over 1 minus r. This is for when r is less than 1. So you just substitute here. So this is the sum of the, what's the question? The sum of the first 5 terms. So our n is 5. So S5 is equal to, what is our A? Our A is 2, open brackets, 1 minus, what is our R? Our R is 1/3 to the power 5, close brackets. This thing is divided by 1 minus 1/3. Now, you can quite alright get this correct, but now how to punch is where people have challenges. So now, how do you punch? You first punch what is in here. So you can say 1/3 to the power 5. Then the answer you find, you say 1 minus that answer multiplied by 2. You write it. Then again you punch 1 minus 1 over 3. Then now you divide that answer into the one you get. Okay. Then that will give us answers in decimal. the standard answers for paper 2 should be 1 decimal place. So your answer when you punch should give you 2.99, or if you round off it will be 3. That is the sum. Okay, then the last question is asking for the sum to infinity. So this is the one I was talking about. Sum to infinity, the formula is there. Sum to infinity is given by a over 1 minus r. So the last part, part 3, the sum to infinity is given by a over 1 minus r. What is our a? Our a is already here. We found it. It's 2. So 2 over 1 minus 1/3. So you should, here you can even use a calculator. You're allowed. You say 1 minus 1/3, you get the answer. You divide that answer into 2, and then you get a 3. That is the sum to infinity. So this is how you solve geometric progression with fractions.